This is a quick review of 7.4. It's another special pattern. Remember, we talked about the difference of squares. If you recall conjugates, remember they're exactly the same except for their sign. When you multiply them, you ended up with x squared minus b squared because the middle terms always canceled out. If you recall, we did this in chapter 6. So this is a conjugate, and this right here, this pattern right here, is what we call a difference of squares, a perfect square minus a perfect square. So that's one of the special patterns we're going to be looking for. So again, when factoring polynomials, the first thing you're going to look for is there a GCF? Is there a greatest common factor you can take out? The second thing you're going to look for is special patterns. Is it a perfect trinomial square, or is it a difference of squares? And go from there. So here's an example. Is there a GCF? Do they both have x's? No. Are they both divisible by 4? No. Divisible by 2? No. So there's no GCF. So there isn't any. So now we're going to look at a special pattern. Well, notice we have a binomial. So anytime you have a binomial, you're going to ask yourself, is this a perfect square minus a perfect square? Well, 2x times 2x was a perfect square. And 5 times 5, so it's a perfect square. And they're subtracting. So this is a difference of squares. So when you factor that, you're going to make that 2x minus 5. (2x plus 5). Because remember, this becomes the conjugate. Conjugate becomes this. So you're going to now take each one of these, you're going to make one negative and one positive. So this difference of squares, this is how you would factor it. This is your final answer. Let's look at another one. Okay, is there a GCF? Okay, well, they're both divisible by 3. So we could take a 3 out. That would leave me with a 3 and a 12. But I'm not going to do that because this is a perfect square. And if it's a perfect square, I'm going to say, well, 3x times 3x, and this is 6y times 6y. So they're perfect squares already, and they're subtracting. So that tells me I'm going to have 3x 6y times 3x 6y. One's going to be positive, one's going to be negative. They're going to give me conjugates. And so there we have now factored that out. Here's one. Do they have a GCF? No. Is it a special pattern? Well, this one you got to think about for a minute. Okay? We know that 4 times 4, right, gives me 16. We know that b times b, right, will give me b squared. But here you have a to the 6th. Well, if I have a cubed times a cubed, remember when you're multiplying, right? When you're multiplying, you add exponents. So a cubed times a cubed does give me a to the 6th. This is a perfect square. And c times c, right, is a perfect square. So that means that my answer is going to be 4a cubed b c, 4a cubed b c, and they're going to have opposite signs. We're going to have conjugates. That's how we ended up getting that negative. So that is this difference of squares does factor into a conjugate. All right, so again, is this a difference of squares? You only need to check that is if it's a binomial, right? So in this case, we know that 1/3 times 1/3 gives me 1/9. We know that 1/2 times 1/2 gives me 1/4, and x times x gives me x squared. So these are perfect squares. So my answer is going to be 1/2 x and 1/3. 1/2 x and 1/3. This is a difference of squares, so you're going to have your opposite signs. You're going to have a conjugate. Now if this had been a positive, it would not be a difference of squares, would it? So you couldn't factor that. Here's one. Let's see. Well, I know that x squared times x squared gives me x to the fourth. I know that 1 times 1 gives me 1, so they're perfect squares, and we're subtracting. So that means that this would be x squared and 1, x squared and 1, and you're going to have opposite signs. So this is a difference of squares that factored into a conjugate, right? Always when you're factoring, you're going to look again and say, hey, can I factor again? So you're going to look at this one and say, can I factor again? Well, this is a perfect square. This is a perfect square. But is it a difference of squares? No, they're adding here, right? So this won't factor again. But let's look at this one. Is this a difference of squares? Well, that's a perfect square, and they're subtracting. So this one right here can factor again to be x plus 1, x minus 1. All right? So this factors again, and you still got to bring this down. Now we have completely factored the x to the fourth minus 1. All right? It's going to be all of this right here. So you're always going to ask again, can you factor again? All right?